Good morning. I'm Barry Wise, president of Eigenvector Research, and this is everything you need to know about importing data with Solo and PLS Toolbox. And I'd like to introduce our Lyle Lawrence is going to be doing this webinar. Lyle's a staff scientist and developer here at Eigenvector. He's our newest staff member, and he's been especially active with our help desk. So if you've had any help desk questions, you've probably interacted with Lyle. And with that, I'm just going to turn it over to him.
Thanks, Barry. Yeah, just a quick introduction about me. I was introduced to PLS Toolbox and Solo about 5 years ago and started using it as an end user. And so that's my perspective is as an end user, and I try to have that end user hat on whenever I'm doing software development and writing new functions for the software or adding things to the software. So I always try to keep that hat on. Some notes about the webinar today. It's being recorded and it's going to be posted on our website at eigenvector.com, resources, webinars. And there's a list of all of our previous webinars. This is the 8th webinar in our webinar series, and the list is growing and will continue to grow. Our Scott Koch will act as moderator today. And if you have any questions, please post in the chat and Scott will relay them. Also, please note that everyone's muted on entry, and we ask that you stay muted. And another note, I'll be using Solo plus Mia version 8.1.1 on Windows today. Everything will work if you're using PLS Toolbox on a Mac or Windows or Linux, or if you're using Solo on a Mac. So there should be no issues there.
Yeah, good morning, everyone. Like Lyle said, please post your questions in the chat, and I will relay them to Lyle when there's a pause. And I think we suspect we could get lots and lots of questions coming through. So maybe we could be a little bit sparse with our questions to begin with, and then and try and hold them till the end unless they really are pertinent to what Lyle's doing at the time. We already have our first question, which is somewhat ironic in that Greg here is asking if you can, if you have an X block with a timestamp and a Y block with a timestamp, can PLS Toolbox match the two, even if the X block has missing data? The answer is probably yes, using our matchvars function. You just have to put that timestamp in the axis scale of your data set. That I think is a little bit outside of today's webinar, but we were just talking about a webinar dedicated to sort of data arrangement and dealing with other aspects of like missing data and joining data. So look up matchvars Greg, and I will let Lyle take it over here.
Okay. Thanks, Scott. Thanks for the question, Greg. So I'm going to continue on. A little quick outline of today's presentation. We'll show a quick flowchart about how things are connected in the software. And then we'll talk about some assumptions about the data arrangement that the software makes. Most of this presentation is formatted in a checklist. So these are a list you should kind of consider when you start thinking about importing your data into Solo or PLS Toolbox. And then we'll look at some examples. We'll look at our built-in importers, built-in importers for proprietary file types versus standard file types, and we'll look at some spreadsheets, so Excel and CSV files. We'll look at the import tool window, and we'll do a quick example of adding some metadata via our DataSet Editor. We'll take a look at our experiment file reader, which is nice for doing building regression models and importing data for regression. And then we'll take a quick look at hyperspectral data and loading some hyperspectral images and or just images, and then building a image data set object. So this flowchart kind of has a lot going on, but the main takeaway is you have your raw data, and it's gonna, when you go to import it, it'll use a particular file reader function, and then this is gonna import your data as a dataset object here. And then when you go through the modeling process, you'll have your model object. And the main takeaway is that this dataset object and the metadata that's included will be shared with the model object. So so that information will be there. So it's important to kind of get your data arranged and import it with that metadata that you want. And going forward with plotting, you'll be able to use that metadata in your plots. And we have our previous webinar was on plotting and how to best plot things and visualize visualization techniques. So data arrangement, the software assumes the data is arranged in a matrix where the rows correspond to the samples or observations and the columns correspond to variables. So we want to get our data into this form. So this is a simplified form. And there are techniques. Our DataSet Editor allows you to transpose your matrix. So if you import it, when you notice that your variables are actually your rows and your columns or your samples, you can transpose it, and you can also transpose it upon importing. And we'll take a quick look at that throughout the presentation. So here's the import checklist I mentioned, and this is just something to think about when you begin to import. The first step would be to say, or to ask yourself, does Solo or PLS Toolbox have an importer for the proprietary file type that I'm working with? So this would be the proprietary file type for the instrument software that you're working with, and we'll look at some examples of those. The next question would be, can the instrument software that I'm working with export to a standard file format? And if you can't do either of those, then if you can get your data into Excel or a CSV format, then you can get it into Solo or PLS Toolbox. So we'll kind of go through each of these in more detail. Starting with proprietary file formats, so we have lots of built-in importers, and we have a lot for proprietary file formats. So examples of proprietary file formats would be a Bruker Opus file, or a Thermo Fisher.spa file, or a PerkinElmer.sp file. So I'm going to switch now to Solo Mia. So I'm going to minimize PowerPoint, and I have opened my Solo Mia workspace browser window. I'm going to do a quick tour of this window. So on our left here, we have our analysis tools, and these have things like all of our modeling methods, like our decomposition methods. Here we have PCA, and our regression methods. We have PLS here. Here's our current workspace, and this is where our loaded data will be and the variables that we're working on. And then here's our model cache, which kind of keeps track of our modeling activity to lets us not lose any pertinent files. If we happen to remove some files, we can always get it back from our model cache. This current folder here is the folder that it's the current folder that it's in, and you can change this by clicking this change current folder button, and you can navigate to another folder if you want, or you could click this this button here to go up one folder. Another important button here is this import data button with the colorful arrows. You can click that and you can choose files to read. So different ways. There are several different routes. I'll call them routes of getting data into Solo or PLS Toolbox, and I'll kind of highlight some of them as we go along. And the first route I want to highlight is through the File menu. So on this workspace browser, you can go to File, Import Data. So this is where you can see our extensive list of file importers, and it's starting to grow. It's starting to, we might need to clean this up a little bit. As you can see, it's kind of getting off screen here, and it's kind of organized in three sections. This first top section is kind of standard for files or more common formats like CSV or text or Excel files. This middle section has More commercial formats, this is where you'll find proprietary formats like an Opus file or a Omnic file or Perkin-Elmer, things like that. And it also has some of our standard formats like the SBC, the Grams Thermogalactic file, SBC file. And then our bottom section here is going to be if you have Mia Toolbox installed or you have Solo plus Mia. This is where we see file importers for image file types. And we'll touch on those a little bit at the end. So I want to import a Bruker Opus file. So I'll select Bruker Opus here. And I'm going to navigate to this Bruker, this folder here that contains Bruker files. And you see that Bruker files have a dot number extension. In this case, we have dot zeros, and then we have a dot one over here. So I'm just going to select this first file and say open. And then it imports this as a dataset object, and it's a 1 by 1491. And we can inspect this a little further. If I right-click on this item, on this variable, and say edit, it's going to launch our dataset editor. So we can take a look at what is all imported. So here we can take a look at the info tab. And sometimes there'll be information that in the Bruker file that will be imported as information. There might be some descriptions about the measurement parameters. This data tab is our data table. In this case, we just have one sample, so one row. And we could plot if we would like to. And our row labels here has some metadata associated with it. We see that the label name that is imported is the name of the file. So we have that .0. So if I go into my Explorer window here, we can see that I imported this first file, and that's the name of the sample that came in. So we also have a date and time information, and then it tried to find a serial number, and import that as a class information, but it did not find anything. And then if we go to columns, we can see it imported an axis scale of wave numbers. So all that information was in that Opus file, and then during the import, our Opus reader, the function, parsed out this information and then added it to this dataset object. So I'm going to close this. And I'm going to highlight one other feature. I'm going to go back to our Bruker Opus. So I'm working on a Windows machine, and I can actually select multiple files to import. So on Windows, I'll do a control click to select multiple individual files. Or I can do a drag and select, or I can do select a range by doing a shift click and selecting a range that way. So I want to import all of these files at once. So I'll select all of them and say open. That's going to import this new item's XBlock 1, and it's 7 by 1491. And we can go in and inspect the information again, like we did with the previous file. And you see that very similar. We have our label names are the imported file names, and it found date and time information and imported that as axis scale. And you try to find serial number, but couldn't do that. And then the column labels are going to be the same as before. So it imported the wave numbers. Imported the wave numbers as an axis scale for our variables. So I'm going to close this. That's a quick example of working with Opus Reader, which would be a proprietary file format. And another example I want to show, I'm going to go to my Finder window here. I'm going to go back. And so we have here this SPA file, this Thermo Fisher SPA file, and I can select this and do a simple drag and drop. So this is another route for getting data, importing data into the Solar PLS Toolbox is a drag and drop. And what happens is we have an auto importer function that parses out the file extension, and it knows the correct file reader function to use for that particular file extension. And I'm going to clean up my workspace here. So I want to delete these XBlock and XBlock 1 items. So a little trick, I can just select the one I want to keep, which I want to keep this DMSO seawater, and I can say delete all others. So that'll keep this particular file I want to work with. And we can go in and right click and say edit and look at more information that is brought in. But another example I want to show is, you notice in the Bruker files here, I have a .1, which is a legitimate Bruker file extension. If I try to do a drag and drop with this .1, I'm going to get an error message. It can't pick up the correct file extension as a .1. So we'll say okay, but not all is lost. We'll have to go through the Bruker Opus file and select the .1 here. And we will be able to import that with no issue. The other files, .zeros, we can simply select and drag and drop. And it parses out that .0 file extension just fine. So
this is something unique to the Bruker files.
correct. Yeah, the dot number extension is unique to the Bruker files.
Question, and I'm not sure I understand exactly what the file is here, but it says, can you import Opus dataset files directly? You might have to expand on that.
I think they mean a multi-file, so a Bruker Opus file that has, multiple.
Yeah, I think that
files.
is what they mean.
Okay. I think Bob's answering it looks like.
Yeah, and Bob is saying not yet.
Okay. So yeah, that's a work in progress, and yeah, we're happy to get that out the door as soon as possible. So I'm gonna clear my workspace here. This will clear my workspace. It's gonna ask me if I wanna delete items, all items in the workspace, and it just warns me that this is gonna delete everything, and anything that's unsaved will be lost. So I highly recommend saving as often as possible. For this case, I'm gonna delete, and then I'm gonna go back to PowerPoint. So those are examples of proprietary file formats, and that's the ideal way to get data into Solo PLS toolboxes. If we have a format for or file importer for that proprietary file format.
Hey, can you bring up the list again?
Oh yeah.
I had a couple people ask about just other ones. For example, we had the Hariba EAM files.
Yep. Hariba. Yep. We have so the Omnic SPA, Perkin-Elmer, Princeton Instruments, Siemens RDA file, some Shimazdu EAM files.
Yeah. So yeah, you can always just look at that list and see if the file that you're interested in is listed there.
Yep.
Okay.
Thanks, Scott. So if you don't see a importer for the proprietary file format that you're working with, next step is to see if the instrument software that you're working on can export your data to a standardized file format. So these file formats are commonly used, and some example are JCamp files, Galactic Thermo SBC files, and NetCDF files, and we're going to actually highlight the NetCDF, and we'll work with those. So the NetCDF, this might show up in your instrument software as like Andy-MS or AIA. So this is a network common data form, and it's a common file format for chromatographic data, and it has the file extension .cdf. So I'm going to go back to Solo plus Mia here. I'm going to navigate in my Explorer window to example 2 folder. I want to highlight using this Galactic SBC file another route of importing data. So this is a multi-SBC file, so it has 30 spectra in it, NIR spectra, and I'm going to drag and drop it, and I want to do PCA on this data, so I'm going to drag and drop it right onto my PCA entry here. And when I do that, it launches the PCA analysis window, and it loads the data into the calibration X block. And now I'm ready to begin looking at my data in this fashion and doing some modeling. So now that I brought up this analysis window, I want to also show that you can import data directly into this window. You do not have to go through the workspace browser. And you can do so by clicking on File, Import Data, XBlock, and you get your list of importers here. You can also, you can also do a right click on your XBlock or any block and say import data, and you have your list there. So again, multiple routes to get your data into Solo PLS Toolbox. I'm going to close this window. So I mentioned the netcdf file format, and I want to highlight that because it is a mass spec, a common mass spec file format. So I'm going to find my windows here, use the organization. I'm going to go into my CDF folder here. I want to go into File in Workspace browser, my Solo Workspace browser, and I want to find the CDF importer, and it's right here. So netcdf export from mass spec software. So it's here in the list. We can select it, and I'm going to go to folder 2, example 2 in CDF files. I'm going to select this one CDF file, and when I import, it's going to prompt me for my desired output resolution in master charge units. The default is 1, and I'm going to leave it as 1 for now. So I'm going to just say OK. It's going to import, and it's going to give me this dataset item that's 1195 by 401. And we can inspect this by right-clicking and say Edit. We can look at what is brought in if there's any info. So we see that there is some parameters associated with this file, and that gets imported into the description field here. Note that you can click on this edit button, these edit buttons or add values to change the information. So if I want to say change this name to example CDF, I can do so there, and I can click the check mark and it saves. If we look at the plot, excuse me, we look at the data table here, we can see our data table. And in row labels, we see we have some axis scale information, and this is elapsed time in minutes is going to be our axis scale information. So our CDF, our netcdf reader parsed out this information that was in the CDF file and imported it and automatically imported it. And we can take a look at the column labels as well and see that we have an axis scale here of mass to charge in 1 mass to charge ratio units. So that's our resolution that we decided to import. So I'm going to close this. I'm going to import this same file. I'm just going to do a drag and drop here. So grab it and drag it and drop it. And then I'm going to change this to 0.2, so 2/10 of resolution here. And note the size difference. So now we have 2,000 variables instead of 401. So we can go in there and inspect these. We go to column labels, we'll see we have our resolution in 2/10 of mass charge units. So that was a quick example of working with CDF files or netcdf files. We hope that yeah, this makes it easier for importing mass spec data, and you know, if you weren't familiar with netcdf, hopefully you can find that export option in your instrument software. It should be quite common. I'm going to clear my workspace, and I'm going to go back to PowerPoint. And then moving on, so if you can't find a proprietary, an importer for a proprietary file format, and you can't find a way to import or export your data to a standard file format, the next option is to get your data into Excel or CSV format. So one of our favorite sayings here at Eigenvector is if you can get your data into Excel, then you can get your data into Solo and PLS Toolbox. During importing with an Excel or a spreadsheet, you'll interact with the import tool window. So we'll show this in a few minutes, but I just want to highlight that and note that the import tool window will only show the first 50 rows and columns. Sometimes this takes people by a little bit of surprise, and they think only it's only importing my first 50 rows and columns, but just please note that it's importing all your data. It's just showing the first 50. And the import tool window allows you to set rows or columns as data or to be imported as data or labels or class or axis scale or as included, or you can ignore a column or a row. I'm going to switch back to Mia or Solo Mia. I'm going to navigate back to my example 3 Excel CSV folder here. I'm going to navigate up in this window as well. So I'm going to go to import data and I want to choose Excel file. This is in that top section. And then I'm going to go into that folder and I'm going to choose this LCMS example. So this is the exact same data as we were just working with in the NetCDF file format, but now it's in a CSV format. And we see here the import tool window comes up. And what our parser function does is it finds any numerical data and it assumes that's going to be imported as data. So you can see here our second row here is actually our axis scale, but it says it's going to be imported as data. So what we can do on this first column, we can click on this first column here, and we can change it to axis scale. Now this row will be imported as an axis scale. And you can see the same is happening for our axis scale for our rows. It's seeing that these are numeric, so it's assuming it's data. We want to actually import this as axis scale. And then you can see in this first row, it's a label because it finds that these is characters or strings, and it's assuming that those are labels. So this is going to come in as a label for our axis scale for our a label for our axis scale, and the same is true for the master charge label here.
So we had a question on the sheet that you were showing. There are a couple of zeros. Should we leave them like that?
Yes. Yeah. I think that's part of the data.
Yep.
And then
and you don't need to highlight the entire row. Had another question here. Is you're really only adjusting the column all the way to the left and the row at the very top. You're just telling what rows and columns, what data types are in the rows and columns.
Yeah, thanks, Scott. So yeah, you can only really change this most left, so the first column and the first row is what you can change, and I can go across and change it anywhere here. And again, it just shows the first 50. So I'm going to do a little bit of scrolling, and hopefully it's not too nauseating, but you can see we just brought in the first 50 here.
Yeah, it's assumed that all the meta information really is captured in those first 50.
Yeah. So now that we have our data type set to be imported how we would like, I'm going to click OK.
We had another question there. What does class mean? Classes are groups of data, and it's just another way of another piece of information about your data.
Yeah, and we'll the next example will show setting classes, and we'll actually do another example with setting classes. So we'll have two class setting examples here.
Awesome. We have a few questions on that I'm holding off till then.
Okay, cool. So we can go in and inspect here. We can right click and say edit and make sure our axis scales came in the way we intended. So we can go to row labels and we see we have our elapsed time axis scale for our row labels, and we can go to column labels and see we have our mass to charge ratio for our variables. So next example, we're working with this is a metabolomics example. So I'm actually going to open this in Excel. This is an Excel file, and it has two sheets here. We can see that the first couple of columns contain some pretty useful metadata. We have a index column here. We have a sample ID, so just sample labels. We have a class column, 1 and 0. And then we have a sex column if it's male or female. We also have a second sheet called peaks, and this tells us, gives us metabolite name information. So in the, switch back to the data spreadsheet. So in the data sheet, we just have M1, M2, M3, and 4. So it's kind of shorthand name for our metabolites. In the peaks sheet, we have the full name for our metabolites. So I'm going to leave this Excel open. I'm going to do a drag and drop here. So I'm going to grab this Excel file and just drag it into the workspace. It's going to prompt me for what sheet I want to import. I'm going to say data and say OK. And then we get our import tool window. This is where we can start setting our data types to be imported how we would like. So the index, I'm not terribly interested in the index. It's just the order. So I'm going to ignore. You can select ignore. So in this first row, column 1, I'm going to select ignore. And the sample ID column, I want to leave as a label. So I'm going to leave it as label. We have this class column, and again, it's finding numeric values in this column, so it's assuming it's data, but I know that it's actually class information. And then label here, I'm gonna, or sorry, the sex column, I'm going to leave as, bring in as a label. I can tell by looking at it and that I know my data set that this sex information is actually class information, but for now, I'm going to leave as label. And we can see I'm importing the column. I'm importing the first row as labels. So this will make the M1, M2, M3, and these values or these strings here imported as labels. I'm going to say OK. And now we have this item in our workspace, this data to metabolomics example. And I'm going to go in and edit, and I'm going to add some metadata via our DataSet Editor here. I'm going to change things around. And I'm going to go into our row labels. So see here we have our label information, sample ID. So that looks nice. Actually, you can go in here and change this if you want to sample name, and it updates the set1 sample name for this label set. And here we have our class information. So this is our class 1 and class 0. So it came in as 1s and 0s, but when it got converted into a dataset object, it changed these class names to class 1 and class 0. An important thing to note about Solo and PLS Toolbox, class 0s are reserved for unknown samples. So we don't want to put known samples in class 0. So I want to change these samples from class 0. So I can do that by right-clicking on this class column and say Edit Class Lookup Table. And this brings up our Edit Class Lookup Table. And so this gives us some information about our class sets or our classes. And it says here we have 83 members in class 0, 101 in class 1. So I want to change this to not be class 0. I can do that by changing this class value to 2 and say update. So now it's in class 2 instead of class 0. I can change this name to 2 and say update. So now we have class 1 and class 2. It's important to note that the class names can be anything you want. They don't have to be class 1 or class 2. I could change this to say B, for example, or A, and say update. And then I'm going to say OK, and we'll see their class names have changed to A and B.
Yeah, we had a question about, can you have multiple classes for a single data point? and you can. You use a different class set. So you could add another column of information about classes assigned to your samples.
Yeah, that's a great question. And we're going to do that right now, actually. So if you recall, we brought in that column called sex as a label set. So this has male, female information. And we can see it lines up with our class information. So male would be class A in this case, female would be class B. So I think that male and female is a better descriptor of our classes than just A or B or class 1 or class 2. So I want to use this label set as a class set. And so the easiest way to do it, now that I have it in my label set, is to right-click on this label column and say use this class. And it's going to copy it to class set 2. So now if I go to my class and I go to this drop-down, I see I have a second class set and it's called sex. And I go to it and I have my male and female class set. So I'm going to change this.
In this example, that both class sets match each other just because they're from the same information. But obviously you could make a class set that was an entire different grouping.
Yes. So that's an example of quickly adding a class set if you have it as label information. I'm going to go to my column labels tab here. We see we have a label for our class. So this would be our shorthand metabolite 1 or M1, M2. And it has a class name or a label name as class. I'm going to change this to metabolite. I'll call it short. Nope, that's not how you spell short. And if we can recall from our looking at our spreadsheet that we have more, we have the full length names of our metabolites. So I'm going to go back to the spreadsheet here. So here in this sheet, we have the long names of our metabolites. So I want to get this information in through my dataset object. And I can do it very easily here in Excel. I can just select this whole column and say copy. And then I can go back to my dataset object, my dataset editor, and I can go to set 2, create a new label set, and say paste. And then it adds that label information to this new label set. I can change this name to just simply metabolite. And a quick example of why this is useful. If I create a plot, if I do a plot here, and I want to plot the mean of the data, which is shown here. Let's say I want to label these peaks here. I can do so by going to View, Labels, and now I have these label sets that I can choose from. So I'm going to select metabolite. It's going to get pretty cluttered here. So you can see, we can see some names clearly, but a lot of them are on top of each other. So this is where that metabolite short label set will come in handy. If I know that, M45 is citric acid, then I know that I have that information. So a quick example of how that can be useful for us. I'm going to close this. I'm going to save this window. Now that I've done all this work, I want to save it. So I'm going to save it to a workspace here. And I'm going to close it. And this is just I'm going to go back to our solo Mia. So now I have this item saved here. Just note it's saved in the workspace. So if I clear this workspace, I'll lose all that information. So I want to right click on it and say, I want to save this to file so that I don't lose this. And I'll give it a file name here. So I'll just say example, save, and then I'm going to save it as this item. We'll say save. Now we have that. We go to our Finder window. We go to, I saved it in the wrong folder. I saved it here. So yeah, so it's saved in the right folder. That can be easily fixed. I'm gonna close this Excel spreadsheet.
while you're doing that, I'll mention that we had a question about setting some of those label and class ignore um, uh, functionality with a command line function if you're using PLS Toolbox and MATLAB. You can do that through the text reader function. It's a little bit complicated because there's a lot of options in there, but you can look at our documentation and figure out how to do it. There's a link in the chat.
Thanks, Scott. Okay, I'm gonna go through this example pretty quick. So this is using our Arch data, and this is in a CSV format. So Scott mentioned the text settings, text reader. So the text reader function is kind of controlling these text import settings. I just want to select graphical because I want to use that import tool. And note that I mentioned transposing. So here in this text import settings window, there is a way to transpose your data when you import it. So I'm going to leave these data types are set correctly. I want to import this first column as labels and then this second row as labels. So I'm going to go ahead and do that. And I'm going to edit this data. So this is a quick example of, I hope, a good tip for setting classes. And you can see here, if you look at our sample names, we have K, we have multiple samples with K, we have multiple samples with BL, and then multiple with SH. So I want to set, this seems like logical class information. So I want to set these first 10 to be K class. And so I can do that. I can click on the first row and I'm on a Windows. So I'm going to do a shift click on the last K and it selects them all. And I can go over here to new class and do a drop down and say new class. And I can change this to K class. And it's going to set all of those selected samples to be the K class. Another way to select a lot of samples is I can do a bulk selection change. So I right-clicked on this label. I can also right-click on the class, or I can click on a row and say bulk selection change. I'm going to right-click on this label tab, say bulk selection change, and I'm going to select all the BL samples here. And I can select the first one and do a shift. And I can say, oh, I left some out. And I can say, okay. So it selects all of those, and I can go do back to my class dropdown and say new class, and this would be BL class. And I can go through and do that for the rest. And so that hopefully that's a neat trick for those who haven't seen it or weren't aware of a quick way to assign class information.
Can you right click on the class header there and show how you could just copy and paste class information? We had a question earlier about assigning class information from somewhere else, like an Excel spreadsheet. Yeah, you could copy your class information, as a column in Excel, and then come to this menu and select paste, and it would paste it right in there.
Yeah, they're all of these have a copy and paste functionality. Yeah, thank you, Scott. Cool. So I'm gonna close this window. I'm not gonna save it. And I'm gonna clear this workspace. I'm gonna go back to PowerPoint. So a question we often get is, why do some Excel files fail to import? And the answer or suggestion is, or what we recommend is, some Excel files with unusual row or column content may fail to import or import incorrectly. And this could be due to like empty cells in the top left corner. We recommend, if you come across this, is to try saving that Excel file as a CSV file type and try importing it that way. So the next example is going to be our experiment file reader. I'm going to try to go through this pretty quickly. So this, you use this when you're building a regression model, like a PLS model. And this allows reading in a file of a CSV or Excel or text or .exp file format. And this is going to contain file names or path. It's going to contain reference values, and it's going to contain a flag of if that sample is going to be a calibration or validation set. So here is a little example image here, screenshot, where we have our file name, a reference value, and our cal-val flag. And we can see we have file1.xyz, just some random file format. So I'm going to switch now back to SoloMia. And I want to navigate here in Mia Toolbox, or in SoloMia, to my example 4 here. So I also want to do it in this reader. But here you can see we have our Excel file that has our experiment information. So I'm going to open this up in Excel. And here's our information. We have our file name. So we have file1.sbc. We have our reference value. In this case, it's heptane concentration. And then our cal-val flag. So I'll just scroll and show that the last 5 we want to import as validation. I'm going to close this. Or I'll note one thing here. Note that the SBC files are in the same folder and named the same as our experiment file. So when we load this, it's going to search for this file name in this folder. So let's do this. So let's go to File, Import Data, Experiment File. Here it is. And then it prompts me to pick a file. So I'll select our experiment file. Then we have our import tool again. And I need to change this first row to be imported as a label. Everything else can stay the same. We have our reference value, heptane concentration, coming in as data, so that's good. I'm going to say OK. So then we have a DataSet Editor, slightly different than a little bit different toolbar here, a little bit different buttons than what we're used to. Here we have our reference data, heptane concentration, and our files that is associated with. We can click on this cal-val button here to set the sample status. So since I already had that cal-val flag in my experiment reader Excel file, it knows to import the last 5 as validation samples, and the rest is calibration. I can simply change these if I decide I actually want that one to be calibration. I can go to this drop down and change it to calibration. I'm going to click accept experiment setup. And then it's going to launch my PLS analysis window, and it's going to load the blocks correctly. So we can hover over real quick just to see that in our calibration X block, we have our 25 spectra here in our R spectra. And then we have our reference value in the Y block, calibration Y block. And then in our validation blocks, we have our 5 validation spectra. And then our reference, our validation for our reference. So we can, continue on with modeling if we're interested there. I'm going to close this. So that's a quick example of our experiment reader. I'll close this. Navigate back to PowerPoint. Okay, so getting towards the end here, quickly go through importing images. So we have some importers for common image file types like JPEG and PNG files. We also have importers for SIMS data, so like a .raw, physical electronics, time of flight, secondary ion mass spec data. We have an importer for that, and we'll actually create a follow-on video for this, an addendum showing an example of importing some SIMS data. We can also import HDR files, .tiff files, and several others. And I'm going to do an example showing the Indian Pines data, and it's actually in an SBC format. So SBC format is usually just spectral data and doesn't really contain spatial information for image files. But I'm going to quickly show how to create a image data set from a spectral data set. So I'm going to switch back to Lumia. And I'm going to find my window here. Go to my image files. So here I have some images like this Echo Ridge JPEG. I can drag and drop here. I can drag and drop it into our workspace here. So this is an image, and I can do more with this. If I have Solo Mia or Mia Toolbox installed, I can expand this image processing tree or section, and I see I have this image manager, and I can do a drag and drop. I can drag this item into my image manager, and I have a image loaded, and we can manipulate it here, and we'll, if we want to, we'll discuss this more in future webinars and classes. So I'm going to remove this image. I'm going to leave this image manager up. I have this Indian pine image in a .tiff format, and I can simply, if I have this image manager up, do a drag and drop, and see I have this Indian pine hyperspectral image loaded. So very simple. You can also get to it load by going to the import data, and we have here our image importers, our importers for image formats, file formats. So take a look at those and see if you work with a particular image file, and if there is a importer for your file format. So I want to show an example of creating an image data set. So I'm going to work with this SPC file here. So this is the same Indian Pines data. It's just in SPC, and SPC file format does not contain spatial information, or usually doesn't contain spatial information. So I'm going to clear, I just want this Indian Pines example. So we have this SPC file with 21,000, around 21,000 rows and 220 columns. I want to edit this, so I'm going to right click and say edit. And I'm going to go to the info tab, and we'll see very quickly that I want to highlight or show that the type is data. The type is data, so that's important. And I want to transform this into an image. So I'm going to go to transform, convert to /from image. I'm going to select that. And it's going to ask me, is this data an unfolded multivariate image or a single slab univariate image? So if your image was just grayscale, you would select single slab. Most of the time we'll be working with multivariate images, so I'm going to say unfolded image. And then it's going to prompt me for the size. So I know, since this is my image, that this is 145 by 145. So I'll just type 145, comma 145 and say OK. And now we see that the type has changed from data to image. I'm going to save this. I want to save it to a workspace. I'll just overwrite this variable. I'll close this, and now I can do a drag and drop into my image manager, and I have my Indian Pine image, hyperspectral image. So a quick example of building up a image data set from a spectral data. I'm going to close this. I'm going to switch back to PowerPoint. Getting towards the end here. Quick summary. Just want to summarize that if possible, the best way is to use an importer. So check to make sure your the proprietary file type that you might be working with, see if we have an importer for that, or see if the software, the instrument software, can export to a standard file format. And then always, if you can get your data into Excel or CSV format, then you can get into Solo PLS Toolbox. I think the experiment reader is a cool feature for loading reference values, as well as setting cal-val status, calibration validation status. And we quickly showed how to build an image data set in the DataSet Editor using the convert to /from image. So before we open up for questions, I'm going to throw out a commonly asked question. Can Eigenvector create an importer for my XYZ file type, for some file type that I commonly work with, for example? So the answer is yes, and we're happy to do so, but we need some assistance. It's going to be a collaborative endeavor, and we ask that you, the user, an instrument customer, get from the instrument vendor a specification document that has information about the file type that we can use to create that importer. Also, some instrument vendors may already have a MATLAB function that does import that file format. So you could ask that to the vendors. And if they do, then we can use that to kind of use it and modify it a little bit to have it be included into Solo or PLS Toolbox. Or you can, if you're savvy with MATLAB programming or you want a project to learn how to do MATLAB programming, you can create your own custom importer. So you'll need MATLAB and PLS Toolbox for this. And we have a template for creating an importer, this editds_user_importer.m. So that's kind of a little template just to help you create your own custom importer. And then the editds import methods allows you to add that custom importer to the list of importers that we showed earlier. And here's the URL to our wiki showing more information about those if you're interested. And before we open it up for questions, I'll just say we have some upcoming training opportunities. So we have some online instructor-led classes for machine learning for calibration and classification. So that starts tomorrow, and it's tomorrow and Thursday. We have hyperspectral image analysis class. That's in the 27th and 28th of this month. And then advanced spectral preprocessing. It's coming up June 10th and 11th. So hopefully today you've learned how to get data in, and these classes can show you what to do once you get that data in. And then some upcoming webinars. We have how to build and deploy instrument standardization models. That's coming up June 2nd. And then how to do curve resolution, PLS Toolbox and Solo. It's coming up June 16th. And you can find all this information on our homepage, eigenvector.com. And I'll open up for questions, and this is a picture of my dog who's been my audience member for the past few days, and I think is probably tired of hearing me say proprietary file format. So yeah. And thanks for being here, and thanks for your time.
Okay, I have a couple of sort of pent up questions here. We had a few people asking about files that we don't support, the .srs and .fcs flow cytometer, .dcm, and if you go back a few slides, basically, if you as a customer of an instrument maker can get the file format and send us an example of the file and the format of it, then it's pretty easy for us to write an importer. Without that, it's next to impossible. So we need someone from the manufacturer to really work with us there. And one of those was a Hariba file format. We work pretty closely with Hariba, so I think Bob has already sent them a question asking if we could get a format for that.
Actually, I fired off an email to our contact at Thermo Fisher for that Omnic SRS.
Awesome.
Oh, nice. Yeah, we're always interested in adding more importers and making the software more robust and getting more different types of data in.
We had a question about null values in a data set, and generally those are stored as NaNs, not a number. And now we have a bunch of questions coming up. Could you do a quick demo of changing classes in PCA? I don't. Maybe that's within the interface.
Yeah, I'm not sure if you mean from a plot, a PCA plot, like a scores plot. I think that's.
Let's try that. I think doing a visual class change would be useful to show.
I'm just going to import this Arch data set, and I want to just keep that one.
You can, as you set that up, I'll take a few more questions here. Are there any other dates available for the spectral preprocessing course or webinars? Those dates are set, and we haven't scheduled any more past that. But we record everything.
Those answered, Scott.
Oh, okay.
Yep. They'll be at EigenU.
Oh, there you go. Do you need Mia to read raw files for TOFs data.
We might have,
I forget. Let me just look that up quickly.
I think we added NV outside of MIA.
yeah, we have a HDR NV format for not image data.
But I think
Yeah, the raw
raw
files
is only with MIA.
is only with MIA. Yep.
I think I'm set up here, Scott. So I'm not sure if that question wanted to show a from a plot. So I created a quick PCA model of our Arch data set, and it's a 2PC model. And I brought up the scores plot here, and we can see there's some clustering here. And we have this group over here that has seemed to cluster away from everything. So if I want to change that or create a class set from this, I can select it. And say new class here. So this is actually kind of getting into an update that we're going to have in the upcoming update, and where we'll actually be able to create a new class set. So from that window, so I created this new class and I gave it a name. I'm going to insert a legend. So now we can see it has a new class name. Here are these pink stars. And what you're seeing the other class there, these are the cross-validation information. So I had cross-validation turned on. So when cross-validation is going to go in and create these class sets based on how the data is cross-validated. So that's what the information you're seeing here. We have a enhancement in the upcoming release that will kind of clean this up, allow you to create a new class set if you have a class set already in these plots. So this will change a little bit, but not too much, and just hope it's trying to enhance that feature a little bit.
Yeah, and it's worth pointing out sort of what's going on here is you see the cyan color of those samples. I guess that's the actual color there. But when you make a selection, that's telling the software what samples or variables or whatever mode you're in that you're working with at that point in time, and then you assign a class to that selection. So we had another person ask, about assigning a selection with the search bar. So this was a way of using some information in the labels, for example, to make your selection. So if you go to edit and do the search bar, it's about halfway down. And then turn the labels on. And then you could just type and put a K in there. And you can see that selects everything that starts with a K. And then you could right click on there. That's your, all the samples that start with K now are selected, and you can right click on there on the actual data, and you can assign the class using the search bar there. And if you look at the link to the search bar, it tells you a bunch of different ways to do it. You can do it by sample number. You could do it with a regular expression. You could use other class information there.
Yeah, if I want to select just the first 20, I can say index, and I can say 1 to 20. And I'll select just the first 20 samples. This colon operator is just doing a range here. Great.
Okay, well, shoot, we're just past the hour. Thanks everyone for joining.
Yeah, thanks everybody. Hope you learned something or learned a trick that you weren't familiar with for adding metadata or importing data. And we appreciate your time.
And give us or drop us a line at helpdesk@eigenvector.com if you have additional questions.
Yeah.
Thank you, Lyle.
Yeah, thanks.
Yeah, thanks, Lyle. Thanks everybody for joining.